Welcome to the video. In this video, we are going to learn how we can factorize a given expression using the identities. Let's start the video. First of all, let us learn the two identities that we are going to use in this video to solve the expression. So the first identity that we will be using is if we have the two numbers, let's say A and the B, and the first identity says that the sum of the squares of the two numbers A and B will be equal to the square of the first number plus 2 times the square of the 2 times the first number times the second number plus the square of the second number. On the other hand, the second identity says that if we have the difference of two numbers a minus b the whole square, basically the square of the difference of the two numbers will be equal to square of the first number minus 2 times a times b plus square of the second number. So these are the two identities that we are going to use in this video. We have learned these identities in our earlier class. Let's start with the questions. Is a first question which says to factorize the expression a square minus 10a plus 25. So if we remember the first identity, we are going to use that. Over here we can see over here that the first term a square is already there, and the third term 25 we can write 25 as the plus 25 we can write as the square of the 5. Now, if we remember the first entity, the second entity, because over here minus is there, so that's why I'm thinking of we can use the second identity, which is a square, a minus b the whole square is equal to a square minus 2ab plus b square. So we have a square, we have b square as 5 square, and minus 2 times a times b. Our b is 5, so we have to write 5. Now let's see if minus 2 into a into 5 is same as minus 10a or not. Yes, it is there. So we can apply this identity backwards over here, and which results into a minus 5 the whole square, which basically means that a minus 5 into a minus 5. So that means we were able to factorize the given expression into the product of two expression. That means we were able to factorize. Let's move to the second question. 25m square plus 30m plus 9. Now in this one, what I'm going to think that we are going to use the first identity. And what's the first identity? How I'm thinking of, because I can see the 9 is the square term, the 25m square is also a square term, and over here the 30m, the middle term, is a positive. So the first identity was a plus b the whole square, which says that square of a plus square of b plus 2 times a times b. So let us try to do this. So we have 25m square, which can be written as 5m the whole square. So our first term a is, according to the identity, our first term a would be 5m, and plus 9 can be written as the square of the 3. So our b is written as 3. Let's write the middle term. If we apply the identity, we can write the middle term as 2 times the first term, which is 5m, times the 3. And we have to check. So 30 is equal to 2 into 5m into 3 or not? Yes, 5 times 2 is 3. 5 times 2 is 10. 10 times 3 is 30. 30m is the correct one. So if we apply this identity backwards, we can write the 5m plus 3 the whole square, which can be written as 5m plus 3 into 5m plus 3. So we were able to write the given expression into the product of two expressions. That means we were able to factorize. Let's quickly do this two questions and then using the identities. So over here we have one more question. Now, in this question we can see that all the number in all the terms I can take something common, which is the 4. So I'll first take out the common. So x square 4 has been taken common. So in the first term, x square is left, minus in the second term, if I divide 8x with the 4, we get 2x. And if I divide the third term with the 4, we'll get 1, which can be written as, I can write, so x square can be written as x square. The 1 can be written as square of 1, and 2x minus 2x can be written as minus 2 times x times 1. So I can apply the, which identity is the backwards? I have to apply the second identity over here, the second identity. So 4x minus 1 the whole square. So this is the factorization. Let's go to the next one. uh, Let me shift this a little bit up so that it would be easy for me to write it. So I can write this it over here, 4 and the bracket x minus 1 the whole square. Let's solve this one. Let's factorize this one. 121b square can be written as the square. What is the square? Which number square is 121? The 11. So 11b the whole square. I can write 121. And then plus 16c square, I can write it as 4c the whole square, because square of the 4 is 16, square of the c is c square. And if we apply the identity, the second identity, because over here is negative, so minus 2 times 11b times 4c. Let's multiply this. 11 times 4 is 44, 44 times 2 is 88, so 88b into c, that means 88bc is negative, and over here it is the second term the same. So if we apply the second identity backwards, we will have 11b minus, because over here the second term is the minus, the middle term, 11b minus 4c the whole square. That means for this expression, this is the factorization, 11b minus 4c. So that's all in this video. Do like, share and subscribe the Mathematics Masters, and don't forget to subscribe our page. Make sure that do comment to ask any query, and do follow the Facebook page as well. Thank you.